Hello there, my name's Vince from My Mate Vince, and in this video today we're going to try and fix up this DeWalt tyre inflator. It's coming up with an error 5 code, so it does come alive. It's got an 18 volt battery down at the bottom here. If I turn up the pressure and then press this, it's not making any noise, and then after a little while it will just come up with error 5. There you go. So what is that and why is it not working? Let's take it apart and see if we can fix it. I'm just going to try it with a different battery, just in case. No. Right, okay. Let's take it apart. Right, so there's a load of Phillips screws around the back here. There's also a load of adapters. I'll just take those out there. So apparently the backstory is that it was working and then went to use it again and it wasn't working. So it hasn't been water damaged or dropped or anything. So yeah, should be an interesting one. Right, they're all undone. Let's see if it's going to come apart. Yes, it is. Being held in somewhere. Oh no, there we go. Right, okay. We are in. That looks a little bit crooked up there, doesn't it? Right, so we've got separate motors for this side here than the actual. I thought it would all work somehow off the same thing. Off the ones that's going to do your tyres. So this is the one for the tyre. This is a smaller one for your inflatables. Got a couple of relays down here. And straight away I can see a fuse, F1. So let's see if the fuse has anything to do with it. Onto continuity. No, fuse is okay. I'll give it a nice scrape as well. So you are working, but the pump's not working. So I need to see, is this here? Let me just double check that. So we've got this pipe that goes to here, that goes, into here. So the pipe comes round from here, through, up, in. So let's put the battery back in, see if we can turn it on, and see if we're getting any voltage here, in case the motor's playing up. Happy to work on it because it's only 18 volts. We are in, so let's turn it on and let's put the up to there and let's press it, so it should have voltage now. It's going to turn itself off in a minute. Hold on, let's get there quickly. I presume it's here and here. Nothing there. Is it there and there? That's a red wire and a black wire feed in here. Yeah, it is there and there. Right, has it come up with the error? Yeah, it's turned itself off, so it's come up with the error. So let's do that again. Let's be a bit quicker this time. And go. Here and here. No voltage. So the motor's not getting any voltage. So that's why it's not. That's why it's not working. So from there, the black wire looks like it goes into. Oh no, that's just like a sort of ferrite bead thing. There's another ferrite bead on the red one down here. So 1 second, are they fed? Are they feeding this motor here at the same time? Let's take the battery out. I think both motors, maybe both motors are turning at the same time. Let's go continuity. We're going to red here, and let's go to here. Now is that just getting, yeah, that's going through the motor. But yeah, so it is going to here then. Anyway, I think it is linked to that motor. So when this motor works, that motor should work. So from there then, I can see a big capacitor down here, just in there. From there, it looks like so this board is then fed from, it's so compact in here. It must be fed from the circuit board down here. I wonder would it be these two massive ones here? Or would they be the input? No, they're the input. So this is the input here. So we know power's getting to the board. I need to get to the circuit board because I need to see where the 18 volts stops. We know it's not at the motor, but where is it going to? And we have another pipe coming off here as well, going into this thing. So maybe that's how it knows. That's why it's throwing the error code, because maybe this isn't picking up any off the the air going past it. Maybe this is some sort of air sensor here. But I'm going to start undoing screws. Oh, hold on, we got a connection. Oh yeah, Brian did say that there's that you can plug it in as well, but he hasn't got the adapter. Just seen another connector. Look, we've got a connector here. Whoa. Whoops. Well, the thing is, it's not working on batteries, so let's not worry. Let's not worry about that. Right, we have access now. So what's on this side here? Nothing that we need to worry about. So that's going to be for the backlight. We've got the screen, we've just got lights for the user to see what's happening. And we've got this little wheel up here to mess with. Let's zoom in. It's incredibly hard to work on because of all these wires. They're not on connectors, they're soldered to the board, which I suppose is good for vibrations, but it's just annoying to work on. I hope I don't smash the screen now. Right, let's zoom in and see if we can see what's happening. So I presume this is the massive plane here from, look, motor 1 plus, motor 2 plus. So they are on the same plane, aren't they? Can you see here this massive one? So this, I'm thinking, is going to be going to the capacitor. What's this here? Diode. So it's going to be going from here. It looks like it goes into it's going to be the positive of the capacitor here. And then it looks like it's all this area. But why have we got, where's that going off to? Why is the black on the, that looks like it's on the positive plane. 1 second. Just going to continuity. So annoying that this gunk's on here. So is this going to here? No, it's not. Get out of the way. Is this going to here at least? Yes. It's so annoying, the camera won't even focus because everything else is getting in the way. So that is going to be going up here. How can that be marked up as positive if this is negative here? That's confusing. Kind of looks like the negative is the one that's having the main power through it, doesn't it? Look, with these massive resistors. The whole board's got a bit of a spray on it, you see, and it's hard to get. So basically, when these get turned on, they're putting the power through. I mean, I presume these relays are the thing that's going to be putting the power through to them, because otherwise what else are they here for? There's another fuse here, F2. Let's see if that fuse is okay. Yeah, that's okay. Right, well, I'm struggling to work my way back from here because the thing is, the board's so hard. So watch this. You see how sharp these are? I mean, these are like ridiculously sharp little needle probes. And when they touch together, they make the noise. But watch this. You can clearly see that this is one. Yeah, this is together. But can you see? It's not making a noise. Yeah. And then you think, okay, well, it's got a coating on it, but I have to really dig through the coating to get it. That's annoying, because now I'm saying that it's doing it fine. But look, if I was to go on to something like this here, yeah? Like, I've got a fair bit of pressure on that. I really have to, look, I'm digging in now, and it's only when I really dig in that it makes. So it's really hard to actually trace, because you're not sure unless you dig right in on every single one whether it's going there or not. It's a hard board. It's a hard board to trace. So rather than going from there, let's go from where the battery comes in, because we know that that is working partially, isn't it? Everything's coming alive. So this is where the battery comes in. So I can see it goes through the fuse. So let's follow the positive through the fuse. Okay, so we know that it's okay through the fuse. So here to here, fine. Now we have a diode here. So let's just measure the diode. I won't zoom out, I'll just tell you what it is. So this way round, dig in, 0.6. This way round, open. So I think the diode's okay. Back to continuity. So now, so it goes through the diode. So we've got it going along here, and what looks like it might be going under this relay here. So let's flip the board over and see if we can trace it from this side. Okay, I'm going to go between that bit of the fuse there and see if it comes up on any of these things. Right, it's coming up here. Okay, so we're going to have 18 volts here. We have to have 18 volts there. So we know the positive goes to here, yeah? Positive goes to here, yeah? The relay is going to be the thing dealing with the power. So it's going to be getting switched on here to then allow this to go through to here, I think. Which looks like a massive power rail, doesn't it? So what we'll do is we'll get 18 volts back into it, we'll turn it on, and we'll see what we have at the bottom of the relay. Right, so I should be able to turn it on from here then, shouldn't I? Hold on. So this is the on one here, and then I have to turn this and press in. So that comes on. So oh, it's already on ER5. Why is it already on ER5? Why is it on ER5 already? Why is it already on oh, is it because it doesn't recognise this? Oh, well, that might give us a clue. So what is this? What's that go up to? Oh, that's this thing here. Maybe the sensor's faulty then. That's this thing. That measures the air pressure thing. That measures the air. Right, so that comes up with the same thing. But it comes on straight away when that's not plugged in. But yeah, okay, it comes on straight away, while when it's plugged in it doesn't come on straight away. So it's happy now. Right, so it should be working now. So let's go on to here. It's gone off. So we're going to be using the negative here. Let's see if we can follow it through. Can't tell you how awkward this is to work on. So turn on, turn that. Right, so we're going to have 18 volts here. Yeah, there you go, 19 volts. We're going to have it here. 19 volts.
What follows is 5 minutes of me fumbling around the place trying to work out this relay, but I think I've got it now. Found it. Right, okay. So can you see here we have no voltage? This must be like the low voltage side of the relay. So we've got no voltage there at the moment on this pin and this pin. Then when we turn it on, we still have no voltage. Whoops. We've still got no voltage. But now when we turn this, ready? So no voltage, turn this, turn it on. We now have 19 volts. So that's the low voltage side of it.
A confused Vince amount of time later.
Right, I think this is the one here, yeah? So it looks like this relay here is a 4-pin one, and this one is a 5-pin one. And it looks like this one is being fed from the 18-volt battery, and this one is being fed from the, the adapter over here, that goes into here. So we're concentrating on this one here, because this is the battery one. And it looks like, according to this anyway, if I turn that round, so now we're in the same orientation, yeah? It looks like the coil should be between here and here, yeah? And when that gets energized, it should switch between here and here. So it should switch, the 19 volts is currently here, we need it to go to here. So it looks like, which makes sense, because look, this looks like a massive power rail. But I thought that this was this not coming up as ground or something? So anyway, we should have 19 volts on here, I think. And did we not? We had 19. I'm getting confused. So anyway, I think I understand the relay a bit more. So let's now see if we do have that. Turn that on. Right, we're in here. Let's turn it on. So to begin with, is the coil energized now? I presume not. Well, we've already done this earlier, haven't we? So the coil's not energized now, so that's correct. Yeah. Now, do we have 19 volts between there and the far pin? Here and here. No, but we have it here. Right, this is making a lot more sense now. So now let's turn this on. Turn this. Now do we have 19 volts here? No, we do not. So the relay's not working. Excellent. Right, let's turn that off. Back on again. Let's see, just to double check, if we've got 19 volts on the coil. So we're on there, and there's no voltage. Now I'm going to press in. We have voltage. We have voltage, but yet we haven't got voltage between here and here. So the voltage isn't being allowed to pass through, because we got it here, but it's not been allowed to pass through to here. Excellent. So if I've got my bench power supply and put 19 volts on that pin there, this will probably come to life. Let's unsolder that relay and let's see if we can work out what's going on. Maybe we can take it apart and maybe we can fix it. Well, this relay put up one hell of a fight. I used my solder sucker, I used braid, I used plenty of flux. You're watching this at times 20. It took ages to get it out. But anyway, at long last, it comes out. There we go, we're out. Yes, brilliant. Okay, let's examine this in great detail. I'm going to put all this on the floor. So now, why are you not working? Are you going to come apart, or are you? Oh, you're sealed, aren't you? Oh, that's annoying. It's sealed. Right, okay, so the coil's between here and here. Let's see if we're getting the resistance reading on the coil. Let's dig in. No, we're not. Is that my fingers? Hold on. Let's do it here. Coil's gone. Coil's gone. So there's no way that you can get the switch to go from here to here because the coil's gone from here to here. So you can see there, it doesn't matter about my fingers, look. You can see there's nothing there. Yeah, so that's why we're not getting the 19 volts from here through to here, because this coil can't get energized. Okay, so it's a problem with the relay. Let's see if we can actually just get into it, just for the purpose of the video, to see if there's a way that we can see what went wrong with it.
So this video is a little bit long for an Advent special, so I'm just going to whiz through this bit. I do take it apart and I hope to find a broken bit of enamelled wire from the coil where it meets the legs of the relay, because that's the bit that's going to have the vibrations and stuff. But no, it's absolutely perfect there. Annoyingly, it's failed within the coil itself. Now, I don't know how many meters of coil there is. 100, 200 meters, not too sure. I do unravel some of it in the hope that I might find a break near the very surface, in which case then, if I only unraveled 3 or 4 meters, then I would just solder it up and I'm sure it would probably work just fine. In fact, I know it would work just fine. But no, I've unraveled quite a bit until I get bored, and it's still showing no signs of breaking. So I think it's failed deep within the coil somewhere, maybe towards the middle bit. Anyway, I just want to show you how this relay actually works, because it's easy to see when it's all apart.
You can fully see how it works now anyway. So we have the 18 volts here, yeah, which is in contact with this top one. Can you see? It's not going anywhere. But when this gets energized, this middle bit here gets sucked up because this creates a magnetic field. I hope you like the sound effects, like that. And then this then touches that, yeah, because this also doesn't go anywhere. This thing is not doing anything at the bottom, but that touches that, which then connects this through to this here, which is this whole area here. Yeah, and then it livens up. So if I was just to do that there now, then it would work, but it would keep on working. Yeah, it wouldn't know when to turn off. But when you then put your 18 volts through here and stop putting the 18 volts through here, then the energy goes from here. It no longer magnetizes it, and the spring from this pushes it back down to here again. So it's really good.
Okay, I'm having to get them in from China. There's no UK sellers from what I can see selling the 18 volt one. There's quite a few people selling the 12 volt one. You can tell the difference because the one that I need is marked up as SRG S118. 18 stands for 18 volt for the actual coil. And if you have a look here, it's 112. So that 12 means 12 volts. Interestingly, the DeWalt one that I've got here, the other relay is a 12 volt one, so the power adapter that comes into it must be a 12 volt one. It's just that that's a 5 pin and these are 4 pins. So you can get a 4 pin 12 volt one, but clearly I need an 18 volt one because that's the 18 volt battery. I'm even wondering whether or not, because the thing is, why are they failing? I had a look on Google and there's quite a few people that have them where they failed. So do you know what I'm wondering now? 18 volt, but it's not 18 volt, is it? We know that when you charge up these batteries, they're up on 20 volts. In fact, I think in other countries they're sold as 20 volt items. It's just in the UK they're measured slightly differently, and they're down as RMS or something, and that's why they're 18 volt rather than 20 volt. So now I'm wondering whether, I did buy these ones 18, but I'm wondering whether it would have been a better fix to put in the 24 volt ones. Let me know what you think in the comment section down below, because then maybe the coils wouldn't be burning out if you're using them for 5 or 10 minutes or a little bit longer than whatever the maximum is that you're supposed to use them. Anyway, I've paid £10 for this in total because there was a tax to go on that for 10 of them, so they're working out as £1 each, but I only need 1 of them. But yeah, there was somebody else selling 2 for £6, but I thought for an extra £4 I might as well get 8 more of them, because in the future I might come across them again, because I do intend to do more power tools, so they might be in other stuff for all I know. Anyway, when they arrive, whenever that will be, in a couple of weeks time hopefully, I'll pop it in, and I reckon this is going to be working just fine. But if you could let me know whether you think it would be a good idea to put in a 24 volt one, because then I don't think that coil would be burning out.
AliExpress delivery amount of time later.
My relays have arrived, all 10 of them, and I've checked and we have the same number that's on the one that was in there originally. So let's solder one in and then we need to put it all back together.
So this is going to be nice and easy now. So I solder it in and put it back together. I've got to jog my memory a little bit about putting it back together, because you see a couple of weeks have passed now and it's amazing how easily you forget how something came apart.
Okay, so I was a bit apprehensive about putting it back together. I thought, am I going to have to look up a guide or watch back my video? But what I did is I laid all the screws out in size order. So you can see I've got all these together. I know now they're for the case. Smaller ones were going to be for the board, and in between ones were for this black one, and also holding down this kind of airflow sensor. And I was feeling all proud of myself, and I was about to start recording and say, look, I've done it now, just need to put the cover on. And I thought this would clip in from the outside, but it doesn't. It clips in from the inside. So I've got to take it all apart now just to put this back in. How annoying is that? Yeah, because that's all clipped in. What a shame. Right, if you do one of these yourself, that button is really hard to get lined up because it's so easy to go out of place. But I've managed to get it done now, but that's only because, and make sure that turns as well, that's only because I loosened them all off again and then just tried to force it round with my tweezers. It's really fiddly, that. Now we're together, and that rubber thing goes there. There's another one of them that goes underneath there. It's just to mop up the vibrations, I think, from the motor. Ah, good. Right, everything is back together. Clearly, you wouldn't put all those screws in if you weren't filming it, but I want to finish up the video. I'm confident now it's going to be working. So let's change camera angle and see, when we put the battery in, if it's going to start working. All right, here goes. Turn on. I haven't tried this yet. Do you know what I didn't check? I didn't check the relay before putting it in there. Right, so 4.5 psi. Come on. Okay, maybe error 5. What?
Ha ha.
No.
Ha ha.
The relay was faulty. Hold on, maybe it has to detect pressure on a tyre. Let's try this one. Nothing happening. How weird. No, it wouldn't have to check pressure because otherwise you wouldn't be able to pump up, for example, a football. Surely I haven't put a faulty relay in. Oh my word, I've got to take it apart again. Just to explain, the reason us YouTubers often put things back together is because if I show this working on the bench 10 minutes before the end of the video, you're not going to watch the end of the video. So it's nice just to have a complete video where you show it working at the end. But in instances like this, it backfires because you can see now it's not working. Okay, we've got the battery in. So, first of all, let's see if we have resistance across the new relay. And I'm also going to do the other one as well, see if it's a similar resistance. So, I presume this one is here to here. This is the one that I didn't take out. So that's 390 ohms. And the one that I've put in is 1,600 ohms. So the coil is there. Right, let's see if we can hear it clicking. Right, so I'm going to turn it on now. I heard it click. I heard it click. Error. Then it's coming up with error. Right, let's see if we have voltage then on the output. So I'm going to go between. So that's joining there to there, isn't it? There to there. So where am I going to take my ground from? Where's the negative here? Let's see if I go here, whether or not I can go between here and here, and whether we can see voltage. Well, I could just go anywhere here, can't I? Right, ready? So nothing's changing. Unfortunately, it's a very hard thing to work on because everything's soldered to the board. But we're dealing with this relay here. We know the relay is switching. The problem is there's no power to switch, yeah? So the low voltage side of it's working. But when we turn it on here, yeah? And if I was to go with my meter, if I was to go against the negative here, and this part of the relay, because we know it's switching from there, then right now I should have voltage. And I haven't. So we need to find out why, because look, I've got voltage here. Yeah? I need to find out why I haven't got the 19 volts here. And it would have been easy to do that when I didn't have the relay on. So I'm wondering if I unsolder the relay so I can fully see the tracks. Because on this side it's straight through the board. I don't really know where it goes to. And that's what I need to work out. So I'm going to unsolder that relay. So there's more problems with this than just a faulty relay, which is really, really weird. But maybe the relay went because something else burnt out and it caused, you know, it put too much, I don't know, current or something through those windings. I'm not too sure. Apologies, it's very hard to see. It's a very hard one to film because I can't bend the board where I want the board to be. If I had to unsolder everything, it becomes a nightmare. This board is hard to unsolder components from. It's only small, but it drains the heat away very well, probably because the power planes on it are absolutely massive. Anyway, I'm unsoldering the relay that I've just put in. Luckily, because it's all leaded solder, it comes out a lot easier. We need to find out why the relay's not even being fed with 19 volts. The relay is now switching. The problem with the other relay is it wasn't switching. But now this relay is switching, but it's got nothing to switch because the input pin is 0 volts. So it's switching 0 volts, which doesn't do anything. Right, relay is out. So let's go to the other side of the board. So now we need to work out why. Well, that doesn't make sense because look, that does not make sense. That's on a massive plane. You know what? Have I damaged the wire? Did I damage the wire? But mind you, no, it should have soldered onto that. Right, okay, so we should have, even with the thing off, we should have 18 volts here, which we do. So we should have 18 volts here. Which we do. So why on earth haven't I got it on the other side? Wait a minute. Why haven't we got it on this side here then? So the wire's faulty, but what difference does that make if it is faulty this side? So is it just a soldering issue? Let me see if that wire is actually intact. I appreciate you can't see nothing. I can't turn this thing around. It's a nightmare. No, it's not. It's broken. But so maybe, do you know what it is? I didn't put enough solder through. If I had flooded it with solder, it would have gone right the way through. The wire's broken because look, can you see here? This plane is all the same. So even on the coil, what happens is you've got a permanent 18 volts on these two here, yeah. And then when it gets energized, this puts voltage from here through to here, or the path gets opened, and then it switches to relay, so the 18 volts goes from here to here. But look here, if I go here, you can see that this is all on the same plane, yeah, and that goes down to here, through the fuse onto here. But look, if I keep my probe on this side, yeah, it's not actually coming up on this side here. Can you hear? It's not coming up there at all. So what's happened is when I was taking the old one off, I've pulled through the wire. So what I'm now going to have to do is I'm going to have to flood it with solder so that the solder goes right the way through, because what was happening is this was soldered but it wasn't actually on the board, so the relay wasn't putting through 19 volts between here and here because there wasn't 19 volts on here. So I'm going to have to try to, first of all, I wonder, can I bend? I haven't got any like wire repair anything. So how are we going to do this? I think I just have to flood it with solder because it doesn't matter if it splats around on this side. What I might do is I might keep these slightly proud. I might not have it completely flat, you know. I'm going to have it like that there, and that way then it will allow the solder to get right underneath. So I'm just going to put a little bit on now to hold it. Actually, that's has made the fault more interesting. So let me just put a little bit on here. And get the right level. So I'm going to have it there, yeah? No, hold on. Like that. A little bit more down actually. There you go, you can see that's only a fraction up from there, but it will allow the solder, I think, more chance to go through. Now let's do These ones here. And now I'm going to turn it upside down and I'm going to flood it with solder. Put loads and loads and loads in. Good job I took off that relay, because otherwise I would have been struggling with that for hours and hours and hours. I suppose this, when I was prying up, when I was trying to get the relay off, because it is hard to undo 4 and get it off at the same time. So I presume what happened was I pulled a bit of the wire on the old relay. Haven't got the old relay anymore. I've only kept the cover off it because I could have found the wire. Right, okay, let's flood this one here. This is the one that's playing up. There's no tracks near it on the other side to to melt through, to short with. I'm hoping that's going to have gone through, but it might not have. So let's see now, are we going to have, do you know what, I can't believe I did that with the battery connected. Anyway, let's see now, are we going to have our 18 volts? Yeah, that was a big boo-boo, I should have unplugged the battery. Please have 18 volts here now. So we've got it here, just to make sure. Yeah, now, have we got it here? No, we haven't. We still haven't got it there. Have we got it here? Yes. We still haven't got it there. Oh, no. Okay, let's undo the battery. I have to get that solder to go right the way through. I can't reach it from in here, you see. I tell you what, let's get a wire. Let's make our own. Let's make our own wire. I'm going to get some thin wires and I'm going to shove them in. That's one. I'll have to put more in. I just want to see now if we have, let's just go continuity. Nah. Okay, that's not going to be a satisfactory fix. So let's take the relay off again and let's try to work out what we're going to do here. So at this moment in time, we have one broken wire, which is causing me a headache. I take the relay off again, and guess what? This time, we have 2 more broken wires. Now, my mate Vince has a grand total of 3 broken wires. Right, I've pulled it out, and this is a prime example of a wire. So now I haven't got 1 damaged wire, I've got 3 damaged wires. Look, that's a wire. So you can clearly see it now. So it's like, imagine a tin of soup, open at the top and the bottom, and across. And basically what happens is it connects the top layer with the bottom layer. So these are the wires here. Yeah, through-hole components can be very, very challenging because you think you've cleared all the holes out, but then when you have a big force like this and you pull it, well, you can clearly see it's pulled the wires straight out. So I'm going to have to do lots of work now. There you go, that's it there. So I'm going to have a look at the board and see what I'm going to do. I might have to actually put the relay, you know, quite a bit up and just run wires everywhere. It's going to work fine, it's just the fact that I've made myself a lot of work. Anyway, at least you got to see a via.
An upsetting amount of time later.
Okay, so what I've done is, I think one via was still intact, but I've done it on all of them. So this one here just links through from here to here. So I've used one continuous wire from here to here, and that's going to go through, and that's going to be soldered onto this leg. And then this one is going to go under the relay, and it's soldered onto here, which I will also put onto this leg here. This is all one massive big heatsink for that main power rail there. And then we've got the last one going round here, and I'm going to solder that one onto the leg of the relay there. That way then, these vias here are still intact because I haven't touched the top of them. The tops of the boards are fine and the bottom's fine. It's the middle that's not. Well, this one's missing here, but don't worry about that. So basically, whatever's connected to this path here, I don't care where this one goes, whether it goes off here, that's still going to be working. All I've done is I've run wires instead of running that thin tin can of via. So, yeah. We just have to hope that these fit through now. Just barely. Oh, I made some right work for myself there. I know it looks horrible, but the thing is, the wires are just in place of the vias. So now, once it's soldered in, we should at long last have continuity on that input pin. Right, before I clean it up, I'm just going to check for continuity now. So we should have continuity between here and here, which we do, which should be the positive here, which is good. That's going to be going right the way through there, and that's going to be going to the other side there. So that should be all good. Let me get some IPA, clean it up, then I'm going to put some solder mask over this area. Hallelujah! At long last we have continuity on that input pin. So the original fault at the very beginning was just the relay had failed, but in me taking out the old relay I damaged one via, and then with my fault finding and stuff I ended up damaging 2 more. So out of the 4 relay pins, 3 of them had damaged wires. Now I've run these wires. These are from flex cable for mains electricity. Remember, it's only in place of the via. You've still got all the heat sink all connected on each of the solder holes, the pads. They're connected. It's just in place of the via. So you don't have to think, oh, are these wires going to be able to handle the current? All they're doing is passing from one side of the board to the other side of the board. So I'm sure there's just as much copper in these wires as there would be in the via. I think there's going to be a lot more copper in the wires, to be fair. So yeah, apart from the fact that it looks a mess, 100% this will work now. It has to work because the relay was switching before, and now we have an input voltage there. Unless, of course, there's something else wrong elsewhere on the board, but that would be highly unlikely. So I've cleaned it all. I've put nail varnish on instead of solder mask because it's just quicker. I've put it all back together. I didn't really have to make any modifications apart from I just had to snip a little bit of plastic to allow the board to fit in because the wires are hanging off to one side now. You know, they're wrapped around the side of the board. But yeah, it all goes together actually quite nicely. And I'm sure that this fix here will actually be okay. I'm hoping so. If not, Brian can always give it back to me and I can take another look at it because I understand this a lot more now. So next time you see this, it will be back on the table. Fingers crossed, this time I will have a working product to show you. Ta-da! Behold! Turn it on. We have a light. Hey! We have a blow. We have a suck, apparently. Whew, it's noisy. And we should have this here now. Perfect. So I'll tell you what I'm going to do. I'm going to bring it out to the garden. Let's pump up the tyres on my bike that hasn't been used in about a year. Okay, it's blowing a gale here in the UK, so you can probably barely hear me. I've used a torch and it says here inflate to between 40 and 65 psi. So I am going to go to 50. These are completely flat. Right, let's see if it can blow this up. Here we go. And I want to see if it auto turns off as well.
yeah, there he goes, climbing here. How good is that? How good is that? And yes, they are nice and hard now. Well, that was nice and quick. Well, a massive thank you to Brian for contributing to this Advent repair challenge. And yeah, I liked it. It was quite challenging, if I'm honest with you. The relay did cause me problems, but it was still, I think, an interesting fix, and it's a nice item. I hope you enjoyed it. If you did, give it a big thumbs up, and fingers crossed I'll be with you again tomorrow.